Hello, my name is Edgar, and today we are going to do a simple, easy problem on LeetCode called Single Row Keyboard. I really like this problem, and it's pretty easy, so I want to start out with this. So, a few things you should know before you get into this problem is the concepts of a dictionary slash hash map, and some string methods. So, let's get into this problem. First, let's read the description for this problem so we can determine what we want to do to solve it. So the question is asking, there is a special keyboard with all keys in a single row. Given a string keyboard of length 26, indicate the layout of the keyboard, indexed from 0 to 25. Initially, your finger is at index 0. To type a character, you have to move your finger to the index of the desired character. The time taken to move your finger from index I to index j is I minus j. You want to type a string word. Write a function to calculate how much time it takes to type it with one finger. So let's go to the drawing board. Okay, so let me first restate the keyboard problem again. So P here, given a special one row keyboard, KB for short, and given a word we want to type out, return the amount of time it takes to type out that word. To type word. Now note a few things. First, where our finger is going to start in a special keyboard is going to be at the 0 index, or at the very left side of that keyboard. So start at 0, and to get from one keyboard or one key to its adjacent keys is going to be 1 unit of time. So 1 unit of time to get to adjacent keys. So note that this doesn't mean that we can do one jump from like A all the way to C in just like in 1 unit of time. We have to go from A to B to C, so that would be a 3 unit of time jump. So let's go through an example really quick. So example, imagine the special one row keyboard that we got was just the alphabet, like the regular A, B, C all the way to Z. So keyboard would be A, B, C, D, Z, and the word we want to spell is CVA. The output from these two inputs, the keyboard and the word, would be 4. And I'm going to explain why, because let me just draw out the keyboard really quick. So this is our keyboard, A, B, C, D, E, and then so on. So we start at 0, or A in this instance. 0 is going to be the first letter in this keyboard that we have. Let me also keep track of a count. Okay. So we want to get from A to C to spell out the first letter in this word. So this is going to be a distance of 2, and that's going to be the time it takes to get from A to C. So right now, we add 2 to our count. Now to get from C to B, that's going to take 1 unit of distance slash one unit of distance as well. So distance and time. So we're just going to add 1 more to our count. And then finally, to get from B to A, we're going to do another jump, a 1 distance jump, which is also 1 unit of time. So after we've spelled out this word, we want to sum up all our counts, and that would give us 4. So let's do some quick observations we can make from here. First of all, as the problem stated, we start at 0. What else can I say from this problem? We should also note that the distance formula for this problem is going to be what we do to calculate the time, because the distance and time are like kind of 1 to 1 in this example. So distance is going to be the absolute value of start, whatever index we started at, minus whatever index we ended at. So start, end. So yeah, given these two things, I think we also would have to keep track of a start variable as well. So keep track of start. So the reason for this is because even though we know at the start of our function we're going to start at 0, it doesn't mean that every single time we type out the letter we go back to 0. We don't go from we don't go from A to C, then go back to A, then A to B. No. After every iteration, we want to do that jump or find a distance from the last letter we typed out. So see here, we went from A to C, and then we calculated the distance between C and B, and then B and A. So yeah, we should keep track of start index. That's always changing per loop. So given all of this, let me just quickly write out an algorithm for how we would solve this problem. So first, we initialize all the variables, and then we're going to loop through every character in the / letter in the word that we're given. Loop through each letter in word. And each loop we want to calculate or find the index where we are trying to go to. So like the target letter we're trying to type out. In this case, I'll just call that variable end. So n is going to be equal to. So an easy way in C# to find the index of any letter or character or like some pattern is to use index of. So what this method does is it takes in two parameters. One is going to be the pattern that you're looking for. So in this case, the letter in the word, and then the second parameter would be the keyboard, and it's going to return to us the index where we first see that that letter. So yeah, that would be a quick and easy way to find the index. So is equal to the index of letter in keyboard. Finally, we're going to increment count, which is going to keep track of the amount of time it takes to type out this word by distance. The distance that we calculate from every single time we find the end and the start indexes. So count incremented by distance. And then finally, what we're going to do is we're going to set start equal to whatever the end index was. So we can remember where our finger was at last. And after this loop is finished, we want to return to count. And that should give us our answer. Return count. So a quick time and space complexity of this algorithm. Times would be O of n squared, and space is going to be O of one constant. So it's going to be a constant time. So the space is fine, but the thing that's really a bottleneck for our algorithm is the n squared time, because it's very slow. And the reason why we have this slowness is because in this line here, when we're using the index of method, that method under the hood is also doing its own search, but this time it's searching for that one letter in the keyboard string that we're given, and thus for every single time we're looking for that index, we're going to do that search as well, and that's going to basically slow down our algorithm tremendously. So an easy way to make this much more faster is that we can try to get constant time lookup for every single letter in the keyboard, and we can get the index that way. And we can do that by creating a dictionary that stores key value pairs, where the key is a character in the keyboard, so ABC or whatever, and the integer or / value in the key value pair is going to be the index that that letter is in the keyboard. So our algorithm updated with that extra dictionary is going to be the same as this, except we're going to start out creating the dictionary. So create dictionary, and then we want to populate it by looping through the keyboard array, or keyboard string, populated by keyboard string with characters and their indexes. And after we do that, then we're gonna go into this loop like we did before. So loop through letters in Word. And this time, instead of using the index of to calculate our end index, we're going to just look up in the dictionary the character or / the letter that we're looking for, and it's just going to immediately give us the index. So n is going to be equal to dictionary at letter. Now the rest of the algorithm is the same. Count incremented by distance, and then start will be equal to end. And after we return a count, and that would be the algorithm we're gonna be coding out in the LeetCode editor. So a quick time and space complexity of this algorithm. The time is gonna be O of n, so it's gonna be linear time, a lot quicker than quadratic time. And space is still gonna be constant. And this is because even though we're creating a dictionary, so we're gonna be using more space, that space is never going to increase based on the input, because the keyboard, as outlined in the problem, is always going to be 26 letters long, because the keyboard is always going to hold some sort of a combination of the alphabet in some random order. So yeah, we are going to go by this algorithm when we type out the solution, so let's get to that. Okay, so now we're going to type out the solution as we described it in the algorithm that we wrote out on the whiteboard. So first what we want to do is create the dictionary. So it's going to be of type car int, which is called a table, equal to the new class instance of dictionary. Hopefully the keyboard sound isn't too loud. I recorded this earlier and it was like really, really loud. So it's just like my second attempt. Trying to be very, very soft on the keyboards. But yeah, now what we want to do is populate the table dictionary we just created with the key value pairs, where the key is a car, which is like a letter in the keyboard string that was inputted to us, and where I is an integer, but where where the int is an integer, where the that is an index on the keyboard. So we're doing that so we get quicker access to every single index in the string keyboard. So yeah, for int I equals 0 as long as I is less than keyboard dot length. And all we gotta do is add another entry into the table dictionary. So add keyboard at I and I itself. So now we have quicker access to all the characters and their indexes on the keyboard string. So we want to initialize some variables. So we're going to initialize an int variable called start, and as outlined in the question, we always start at the 0 index, or at the very left side of the keyboard. We want to create an end index as well. We're not going to initialize with any variables or any like solid value, and then we're going to keep track of a count, which we return at the end of the function. So the count is going to be like how long it takes to get from one letter to the other. So yeah, as I said before, we're going to return count at the end of this function. And now we're going to do a for each loop. So for each car C in Word, where Word is what was sent to us in this function, what we want to do is we want to calculate the end index, and that would just be equal to table at C. Now we want to calculate how much to increment count by, so we're going to do count incremented by the math.absolute value of a start minus end. So this will give us the distance between start and end. Note that it doesn't matter if you do end minus start, it will give us the same answer because it's just the absolute value of that expression. And then after that, we want to set start equal to what end was, because when we do the next iteration, we want to keep, basically, if I want to go from A to B, I start from A, and then I end up at B. So now B is going to be my next start. In the next time we want to go to another letter like C or D. So yeah, that all looks good. Let me click submit, and awesome. So that was the single row keyboard problem. Thank you so much for watching, and I'll see you another day. Bye.